welcome everyone. We actually had planned to have this session already a month ago and we had to delay it, but today I have Sharat Chandran R here and Sudarshan Soma, and they will both present the new capabilities of the Go driver if it comes to JSON. So this will be both slides and a demo, I believe. And if you have any questions, please use the Q&A and we'll try to answer them live, or we're going to answer them at the end. And with this, please get started.
Okay.
Over to you,
thank you, Bida. Can you hear me and are you
Yes.
able to see my PPT?
Yes.
So hello, everyone. Welcome to today's discussion on using JSON data in Go-based applications with Oracle database. So in this session, we are going to talk about Oracle's Go driver for accessing Oracle database called Godror, as you can see from the title slide. It is created by a community contributor called Tamas Kulashi, which we will talk about much later. And we will also discuss about the JSON features that we have introduced in the latest versions of this Godror driver. So talking about myself and my team, my name is Sharad, and I am a product manager in the data access development group for Oracle database. Meaning I'm one of your technical points of contact for any questions related to interfaces, drivers, and other solutions developed by Oracle for data access. So I liaise between Oracle's development group, management, and with you as our customers and users to bring you the right features and capabilities in all the relevant products. So I have with me my colleague, Sudarshan Soma, who is online to help with the demo and questions. So he is an important contributor to the Godror open source project from the Oracle side, and he will take you through the actual demo with JSON. So quickly talking about what my group does, my wider group looks after all the language APIs for accessing Oracle database, whereas my core team, they are focused mainly on the C-based stack and drivers which use our C-based stack, which is called Oracle Call Interface. And we have also introduced a new driver called Python Oracle DB, which was recently released, which has both the C-based stack as well as a non-C-based stack portion. So for now, for this presentation, we'll be looking at the Go driver called Godror. So Godror is maintained by an independent community contributor called Tamas Kulashi. But we, as from Oracle, have made significant contributions to this driver. So one of these contributions is the JSON capability with the Godror driver. So, and I would like to take this moment to thank all the community maintainers who do an excellent job creating and maintaining many of these open source language APIs. So, without further ado, let's get into the Go language first. So since Go is a relatively new language and may not be familiar with to a few of you, I have a few slides to give an overview. Then we will get into the details of using it with Oracle database and JSON. So Go is a compiled general purpose language that grew from the history of C and the rise of interpreted languages like Python. It was started by Google in 2007. So what happened was with Python, even though the development cycle or the development time is fast, the runtime is slow. Whereas it is the opposite with languages like C, C++, you find the compilation time slow. So what Go does is it attempts to solve these issues to make a fast compile language for you. The current version of Go is 1.18 and it is an open source. It is freely available for download. So talking about the popularity of Go has been increasing steadily over the last few years. In many surveys, it ranks among the top 10 programming languages. For example, it is number 8 in the IEEE Spectrum top programming languages, having risen a few places over the last 2 or 3 years. And also Stack Overflow has it at number 12 for the in the top programming language and the 4th most wanted programming language. So where Go is used is typically it is used in systems like Docker container system and Kubernetes container systems, which are written completely in Go. Like you may have guessed, these container systems are developed by Google, so they have used Go for it. So it is certainly an upcoming language for systems development. We also see a significant usage of Go language and Go applications on Oracle Linux. So what does Go have? Well, it has fast compilation. especially through its use of graphs for tracking dependencies, and it has simple cross-compilation capabilities across various platforms. And talking about the binaries of Go, they are standalone and have no dependencies, but that's only when they are written in pure Go. Unfortunately, when we are working with the Oracle data space or the Oracle Go driver, we need a C library and shared library, so there will be some dependencies. Then you have all the other things that you expect from in a modern programming language, like built-in concurrency primitives. So you have something called Go routines, which you can get much more detail in the Go documentation, which is used to handle concurrent programs through the use of something called channels. It also provides automatic memory management or garbage collection. It is easily extensible through its various packages. For example, if you want to do a simple println, you have a package called fmt or format, which contains this function, which can be easily used. And also you have type inference, which means that you don't have to explicitly declare the type. And the other advantage of Go is that it can easily integrate with traditional C or C++ code. So what does Go simplify then? There are no forward declarations or header files, and no exception handling. So very simple error checking capability. And there is no inheritance. It uses structs instead of inheritance, and it does not do implicit data type conversions. And also there is no declaration of public or private for its variables or functions. So the public or private access specifier is determined by the first letter of the identifiers. For example, if you have a capital letter, then it's a public function or a public variable. Otherwise, it's a private entity. So since Go is a living language, obviously lots of features are still in the works, and it's an open source. So recently we have generics which have been introduced in the latest Go version 1.18, which is similar to the generics that you see in Java or the templates that you see in C++. So what are the types that you have in Go? You have the normal primitive types. You have the numeric types, integer, floating point, and complex types, which are basically imaginary numbers. You also have string type and Boolean type. In addition to primitive type, you have the derived type. So derived types, you have pointers, functions, which are like a class or an object. So you can pass the functions around. Then you have maps, which are like Python dictionaries or objects in JavaScript. Arrays and slices are self-explanatory. You have structures, interfaces, which we talked about earlier. And finally, you have channels. Channels are used for Go routines, like I said, for concurrent programming. So that gives you a brief introduction on Go. You have much more information in many of our videos, as well as in other videos on Go for details. So I'm going to jump into the Godror driver now. So Godror stands for Go driver for Oracle. So it is available in GitHub. It is an open source database package in Go that allows an Go application user to connect and work with the Oracle database. So Godror is developed and maintained by Tamas Gulashi, like I said earlier. He is a independent contributor, community contributor, who works very closely with Oracle, and he's very responsive. So you can ask questions with him, you can raise issues and understand how to use Godror easily with him on GitHub. And Oracle is also a main contributor here. So Godror is based on Oracle's ODPI-C wrapper, which I'll be touching upon, which is generally used for wrapping around the Oracle C libraries, which makes it easier to call the Oracle C functions for accessing Oracle database. So how do you install this Godror driver? First, you of course install Go, which is available open source. Then you install Godror to this go get command. Finally, you're also recommended to install a C compiler, since we will be talking to C packages or C libraries. Finally, you need to install the Oracle client libraries, because we will use the Oracle client libraries to connect to the Oracle database. So what does the stack look like under the cover? So you have a Go application. When the Go application calls the any functions of the Go driver or Godror, then it passes through various layers. So Godror basically uses something called CGO, which is a library, which is a offered or built-in library within Go. which can interface with the C API to connect to various C libraries. So Godror uses CGO to talk to ODPI-C library, and ODPI-C in turn talks to Oracle call interface, which contains the APIs to connect to the Oracle database. So why are we using Oracle client libraries and Oracle call interface? Because these libraries provides us high performance features like data access, high availability, and more. And it also allows us to configure the way we connect to the database with oraccess.xml file. And also the connection is done through OracleNet protocol. So there you have the standard Oracle client to database version interoperability over the OracleNet. So ODPI-C also provides you statement caching, which makes the Godror or the programs using Godror much more efficient. So let's look at database SQL package. So generally in Go, if you're trying to access any database, you have to implement this package called database SQL package. It is a generic database package for accessing any type of database, for example, Oracle, MySQL, etc. Since this talk is about accessing Oracle database, there is no surprise that we are using this database SQL package. So it is a common database access layer for Go. It has powerful capabilities built in for all databases. It supports concurrent access by Go routines, which I touched upon earlier, context management. You can also manage connection pools, which are available with the database SQL package as well. But Godror provides its own separate connection pooling capabilities through the Oracle client. So drivers for each database brand will implement the interfaces in database SQL driver whenever they want Go applications to connect to their database. So just some implementation on how it is done in Oracle. So Godror in this case talks to ODPI. At the bottom, once it implements the database SQL package, Godror will do the database transactions by talking to ODPI and OCI libraries, which is Oracle call interface libraries. So just a sidebar on ODPI. So ODPI is the Oracle Database Programming Interface for C, which was developed by one of our esteemed colleagues, Anthony Tuninga. It's an open source C library code for calling the Oracle client Oracle call interface, which is the C libraries, native C libraries of Oracle, which is used to access Oracle database. So historically, many languages use APIs, many language APIs like Python, Node.js, they use direct Oracle call interface calls, but now we have added the ODPCI layer to make it easier to call these Oracle call interface APIs. So some of the major ODPI features that you can see here, it enables easier or simpler memory management. It provides resource handle validation and reference counting capabilities, and generally makes the access of these Oracle native Oracle C APIs much easier and easier to understand. So with that, let's now that we have learned about the Go driver and also the Oracle client libraries on ODPI, let's go into the demo and also Godror. Let's go into the demo for JSON cases in Godror. So before that, let's take a look at how we are accessing JSON. So the reason we have now introduced JSON is that in Oracle Database 21C, a new JSON data type has been introduced. So this data type makes it faster to process JSON documents, and it is the best type to store large JSON documents going forward. So you have performance benefits provided by this new JSON data type as well. So when you're using the Godror package, ensure that you're using Oracle Database 21C, and also ensure that you're using Oracle client libraries, which are in 21C version. So the latest Godror package provides JSON support only through these versions of Oracle client and Oracle database. So what examples are we going to cover in today's demo? So we are going to cover 3 examples. One is, how do you bind and read JSON as a string? How do you bind and read JSON as a map? And third is, how do you bind and read JSON as an array? So what are the functions, what are the attributes that you will see in the code. You will see the JSON object, which is created as Godror.json. And also you will see the JSON functions used to give inputs into the database called Godror.json string and Godror.json value. And you to get the output from the database, you have something called Godron.json op number as string. So there may be much more which Sudarshan may cover, but these are some of the examples that you will see here. So with that, I leave the floor open to Sudarshan. Sudarshan, you're there?
Yeah. Thank you, Sharath, for giving the introduction. So as Sharath was mentioning about the different types of the data types or the JSON documents, so I would go over those different types. So initially, I will talk about an application where the JSON document is modeled as a JSON string. So typically, the applications just want to pass this JSON string across the services, stuff like that. I mean, that is one use case. So let us look at this application, how it looks when it is modeling as a JSON string, and it wants to store it in a database, and it wants to fetch it from the database later. So we'll go over those steps and the Go program, how it looks like. So this is the so this is the main function. So the line 23. So what we are doing here is we are trying to open a Godror, that's a database driver which was written for Oracle, and it takes the second argument as the connect string. So the connect string is something like this, which is proprietary to each database. MySQL, it has its own format. So what we get out of this open API is a full object. So essentially we are not creating any connections here. We just get a full object from the driver Godror. And Godror driver is written for the Oracle database. And this line 27, it is it's a kind of a cleanup. When this program exits, the pool has to be terminated, or the connections stored in the pool has to be cleared up. So this is the program. It starts. So the idea is we create a table with just two columns. One is ID and the other is the JDoc. So this is the JDoc column, which has a type as a native JSON. So this is supported from 21.3c, as Sharath was mentioning. So once we get the pool object, what we are trying to do here is we run the SQL query, which would create a table with these two columns. So that is the step. So the DB object has a method called as exit context, which can be used for running the DLLs. And so this is again, once the program exits, we want to drop this test table. So this is the this line is building the input string that we want to write into the database. So this is where the input types an application could have. This is the first type we will be discussing. This is the string, as is the JSON string, the application. So I'm just representing it as an literal in Go with this all special characters, terminators. So this is the new JSON API we introduced. So essentially, whatever the input the JSON string user had, user would get in kind of a JSON value type, passing it to this function. So it creates an instance of JSON value, which can be passed as a bind parameter to this exit context. So it is, we are trying to insert a record, passing the bind parameter of JSON value type. So that is what we are doing in the line 50. And so this causes a database, this causes the record to be inserted into the test table. Because it's an auto commit true, so it gets inserted. So we start then reading the inserted record. So query context is used for reading select statements and kind of stuff. So we get the rows, and this is again Go convention to clean up. So the next thing what we do is we iterate through the rows and we get each element in the table. This is the scan, and whatever we are getting the output JSON doc, this is kind of a representing the OSON format. So we don't know like the JSON document could be of contains any value like an object, array, or a scalar. So we don't know at this point. We get the OSON as is. And we can convert that whatever OSON as a string with this line. So it is like we call a method string on this, and it's a direct way to keep that. And the other thing is we convert that whatever the JSON doc we got, we convert it into a Go type. So this one I am doing it to show that whatever the document that we have fetched from the database, we can convert it into a Go native type, which we can use it for modification and again push it back to the database after the modification. So for doing those stuff like that. So this is just to so this does the conversion line 74 into the Go native type. We just do a assert cross verify the concrete type, and yeah, we print that. So maybe if I just run this program, it would be a little clear. So what I'm trying to do here is Go run. So it basically it simplifies the compilation, creating an exe and removing that exe. So this command is going to take the input file source program. It compiles, because Go is a compiled language. It compiles and generates the exe in a temporary, runs that exe and throws back that exe. So there's a single step to do all these things. So as I mentioned, this is the input that user was providing, user had in his application, in his or her application. So we insert the input into the table, which has the native column as JSON. And this is where we fetch it as a fetch from the database and print it as a string. And we can also fetch it back as a Go type, which we can programmatically modify the JSON. So this is about the first input when the JSON document is modeled as a string. Next, we can go over the other type JSON document, which is modeled as an array. So I am just showing how that it gets represented in Go. So it is array of interfaces. The interface is like a generic data type. So I am taking an array of generic data types, and it has one element for now. And that element is again a map. So, and the map has a key values. And I am taking one of the element in the map itself has a array value. And there is a birth date and there is a Boolean. So I just took a different types of data types that a map can represent. So the program, I will go over the program. It is almost same. The structure is same. So we get the database pool, all the stuff is same. Only thing that changes is the input that you are going to push it into the table, test table. So this is the input representation for the map. And so we are going to get the JSON value for the input using the new API JSON value. So, and we pass this JSON value as a bind parameter to the insert DML, and then we do a select statement, and we get the OSON document, and then we fetch it as a string, and then we fetch it as a Go native type. So it is almost similar to the older one. So we can just show. Yeah. So the same format. The input is what application is having as a map. We insert and we fetch it as a string, and we fetch it as a Go type. So that is about the map type. And there is another thing, an array. So this program is also, the structure is same. Only the input, the array, it's an array represented. And then we get the JSON value out of this input, and we insert this JSON value as a bind parameter to the DML, and we query that, and we fetch the OSON from the database, and we convert it into a string, and we convert it into a Go native. So yeah, it is like we got an input as an array, we insert into the database, and we read it as a string, and we read it as a Go type. Yeah, so yeah, this is all I had. We would be sharing these programs, and so it would be easier to follow. Yeah, this concludes the demo. Back to Sharad. Please take the control.
So can you confirm if you're able to see my screen, Bida?
Yes, I can do that. Yeah.
Okay, so what you saw from Sudarshan was basically 3 use cases where you input JSON data in the form of a string. You can see my video as well, right?
Yes,
Peter?
yes.
Okay. So what you heard from Sudarshan and what you saw in his demo was 3 examples where you can get data in the form, input data in the form of a string, and get data in the form of a string. And similarly, you can input data in the form of a map and get data in the form of a map object, and input data in the form of an array and get it back as an array object. So these are the 3 examples that we have. We can, I'm going to share the examples with Bida as well. So there are a lot more things that you can do with Godror, but as far as JSON is concerned, we are just getting started. We plan to add more support for other JSON features as and when we have additional support in the future Oracle database releases as well. So please keep in mind that since Oracle, the Godror driver depends on the Oracle client libraries and the Oracle database. So based on the new features that we have for JSON, the Oracle Godror driver will evolve accordingly. So there was a question where we asked, there was a question on long-term support. So this generally depends on the Oracle database. Bida, you can probably attest to that. So based on the long-term support is decided by the Oracle database team, and based on that, you will see which versions have long-term support and which do not. But this Godror driver depends on the Oracle client libraries and the Oracle database. And what you see on the screen here is the set of links that you have where you can go and check out the Godror source code and Godror examples. And you have a blog as well. We have a blog for you as well, where we just show you how to use JSON with Godror along with the 3 examples that Sudarshan showed you. So all those code snippets are available in the blog site as well. So with that, I would like to conclude my presentation. So any questions from anybody? we are happy to answer.
Thank you, Sharad. Thank you, Sudarshan. Yes, the question regarding 21C and JSON type, we call it innovation release. So it's not long-term supported, but 23C will be the next long-term supported release. So that obviously will also have JSON type.
Right.
At this point, we do not plan to backport JSON type into 19C. It would be like a massive undertaking because it's a new data type and every component would have to be enhanced to also support JSON type. So adding a new data type takes 5 minutes on the whiteboard, but then many people, many months to do the actual work. If you have an autonomous database on 19C, then we actually support this OSINT format inside a blob, so you can get benefits of the same binary format, but that is also limited to an autonomous database. Couple questions. One is there any like programming languages like Java have so-called POJO mappers where you do have a class definition and then you use something like a JSON or a JSON, and given some JSON, it instantiates your classes or object. Is there something in Go language itself or like built-in JSON support or JSON mapping, or is it mostly that you kind of extract values and you map arrays and maps like what we've seen here today?
So as far as I understand data, there is no inbuilt or intrinsic JSON support within Godror. So the JSON data type that we are using for Godror is basically a feature of Oracle database. So Oracle database has JSON data type. That JSON data type is returned by the Oracle client libraries, and they are in turn used by this Godror driver. So there is no intrinsic support, but maybe the future there is. Sudarshan.
Just to add on. So the Go language has a JSON package. It works on the JSON string as per the RFC, and it has this marshalling it into a byte and unmarshal it into a structure to an object or an array. So that library is present, but we don't use that directly because of the Oracle types and the OSINT format.
Exactly.
So we have an extended type.
Yes, exactly.
We cannot always use that JSON library because we extend the RFC of the JSON.
Yeah, just to add on to that. So this word was mentioned a couple of times. I think Sudarshan mentioned it, like OSON. That is our binary JSON representation. And Sudarshan mentioned that it's efficient for queries and updates. That's correct, but it also has additional type support. So if you generate an OSINT or a JSON type in the database from, let's say, relational values, and there was like a timestamp or a date or a raw, then this type information would be preserved in the JSON type. So if you consume it from a client like Go, you would know, oh, this value is actually a date or it's a timestamp, etc. And JSON, like the textual JSON representation, doesn't have these additional types, so you would always undergo some lossy conversion at this point. And I think this is what, if you use the Go driver, you would get like the full ecosystem of types as well. Good. So if there are any more questions, please add them to the chat or Q&A. So I had a question, just curious, if I'm like a C programmer and one of the hard to debug things obviously are memory related, like memory corruptions, buffer overreads, overwrites, these kind of things. So does the Go language prevent this to a large extent, similar to Java, where you can't?
Go is a memory safe language, so there is no raw pointer access.
Okay.
So we don't get into zigzag, null pointers, double face kind of stuff.
Right.
So that's where there is an unsafe package in Go. So if you have something which is not memory safe, then it provides a way to access the raw pointers. That is, so as a Go, it's a full memory safe, but you want to do something efficient. It Go always provides an unsafe package. So you can put, you are responsible for the memory safety. So when you start using the functions under the unsafe, so you are taking care what you are doing is right. So
yeah, so this would be a big simplification. So Go programmers, do they typically are former C or C++ programmers, or is that hard to say? Could even people from Java go to more easily go to Go because they have the same memory, garbage collection, etc.?
Yeah, like Go has the garbage collection, just like Java.
Yeah.
But it tries to make simple on the object-oriented programming. So it gives a minimal capabilities, like there is no multiple inheritance.
Yes.
So it provides the interfaces. And so I can say it's a mix of C and the best of C and best of C++, but removing the complexity of C++.
Yeah.
Like exception handling is not there. There is no multiple inheritance. You don't need to worry about memory leaks. You don't need to worry about memory ownership. So it tries to give the best of C++ design thing and as simple as C. So somebody can just quickly, because there are minimal options, so he will feel it simple.
Okay, great.
Okay.
Maybe.
So there is one more question, I think, Sudarshan, where they're asking, how does Go ensure fast compilation? So can you expand on it?
The fast compilation, because the Go has a way kind of a modules. So everything functionality and expose it as a module. And when you link all the modules, you need to ensure the modules are forming a tag direct as a application like Godror. It depends on the Go sequence, on the package. As you draw this dependency, there will be any and the Go. So when you don't have a cycles and you form a DAG between the dependencies for the modules, you can always run the in a parallel fashion, because the DAG has the siblings which are all which can be run parallelly. Like they could be run parallelly in multiple cores. So it gives you a task kind of a thing where parallel modules which can be compiled. So those happen parallelly. And they don't use the header files. They use the import kind of stuff. So now that reduces the compilation time. We just import the functionality, not include header files. So these two things make the Go faster.
Yeah, we have one more question.
Does it answer?
Yes, Sudarshan. So basically what I understand is through the use of its directed acyclic graphs, it runs a lot of modules parallelly. It compiles a lot of modules parallelly, thereby achieving a faster compilation than C++. Oh, so I think we lost him.
Yeah, there was one more question in the chat about array handling. If this is the same as Python or I guess JavaScript, where the array, like the first element in the array starts with 0 or array name 0. Do you know the answer, Sharad?
I think it starts with 0, Sudarshan.
Yes. Sorry. Indexing in array is same as in Python or C. It starts with index 0. Yeah, that's correct.
Okay, wonderful. Thanks a lot, Sharad. Thanks a lot, Sudarshan.
Thank you. Thanks.
And if there are no more questions, then I think we can conclude here.
Okay.
Thanks, everyone.
Thank you. Thanks. Thanks, Sudarshan. Thank you, Bida.
Sure. Bye.